We've talked a lot so far about radicals, square roots, cube roots, things like that. One other thing we need to deal with is fractional exponents, and that's exponents that are fractions. It's that straightforward as far as the name. So just some reminders first. Square root of x is the same thing as x to the 1/2. The cube root of x is the same thing as x to the 1/3. So hopefully you can see the pattern there. The fourth root would be x to the 1/4, fifth root would be x to the 1/5, and so on. But they can be a little more complicated than that. For example, if you have x to the 2/3. X to the 2/3 has really two things happening. First, the 2 is your power, so it turns into x squared. And the 3 is your root, so it turns into the cube root. So x to the 2/3 is the exact same thing as the cube root of x squared. And just so you know, there's no order to that. You could square it, then cube root it, or cube root it, then square it. Those can go in either order. The main thing we really want to know how to do, though, is solve equations with those fractional exponents. So we remember here that the 1/2 is the same thing as the square root. So to get rid of that 1/2, we'll square both sides. So the squared cancels out the 1/2 and just leaves you with 3x plus 1, and then 4 squared is 16. You subtract 1 from both sides, get 3x equals 15. Divide both sides by 3 and you get x equals 5. And then down here with this blue example, we have 5x minus 2 to the 1/3. We know that's the same thing as a cube root. So to get rid of it, we would cube both sides. So the 3 cancels out the 1/3, and we just left with 5x minus 2 on this side. 2 cubed is 8. Then I add 2 to both sides and get 5x equals 10. Divide both sides by 5 and I get x equals 2. Now the reason I show you these, even though we've seen some like them before, is I want to try to make you see the pattern here. We get rid of a 1/2 with a 2, which if you notice is just the reciprocal of 1/2. 1 over 2, 2 over 1. We get rid of a 1/3 with a 3, which is its reciprocal. 3 over 1. So 1/3 and 3 are reciprocals of each other. So whenever we're dealing with fractional exponents, to get rid of one, we just do its reciprocal. So here's an example we haven't seen before in class. X to the 3/4. Okay? So first we need to get that x by itself. So let's start with that. Add 6 to both sides. Divide both sides by 3, and you get this. So to get rid of that 3/4 exponent, we have to raise both sides to the 4/3. So again, you do the reciprocal. We took 3/4 and flipped it. It became 4/3. So we do that to both sides. These exponents cancel out, just leaving us with x. And then you can do this part in your calculator. You don't need to know how to do that in your head. Some of them are possible to do, but most of them will not be. So 2 to the 4/3 is equal to 2.52. And I'll just round to the nearest 2 decimal places for the purpose of this. Okay, next example, we have x to the 2/3 minus 3/4 equals negative 1/2. So I would add 3/4 to both sides. Okay, now just like with radicals, we wanted to get the radical by itself, we want to get this fractional exponent by itself. So now we've got it by itself. It's just x to the 2/3, and we get rid of x to the 2/3 with with 3/2, with an exponent of 3/2, because we always use the reciprocal. So the reciprocal of 2/3 is 3/2, so those cancel each other out, leaving us with just x, and then you can plug 1/4 raised to the 3/2 in your calculator and actually get 1/8, or 0.125. Okay, so this is an example of one you actually could do in your head, believe it or not. Again, you can do the cubing and the square rooting in either order, because that's what the 3 means, it's cubing, and the 2 means square root. So you can do this in either order. So if you look, let's take the square root of 4, that would give us 2, and then we cube that 2, that gives us 1/8. So that's how we get that answer of 1/8. Now, like I said, lots of times it won't be possible to do that in your head, so it's fine if you use your calculator for that step. Okay, next example, 5x to the 3/2 equals 25. I simply divide both sides by 5 to get the x to the 3/2 by itself. And to undo the 3/2, I have to raise both sides to the 2/3. So 3/2 and 2/3 cancel out, and I can just do 5 to the 2/3 in my calculator. One word of warning there, if your calculator doesn't automatically put things up in an exponent like a superscript, you want to make sure you put parentheses around it. In other words, in the calculator I would type it as 5 raised to the 2/3. If you don't put parentheses around that 2/3, it's going to be incorrect. It's going to do 5 squared and then divide that answer by 3. So make sure you put parentheses around that exponent. And when you do that, you should get 2.92. Okay, last example. X to the 5/2 minus 8 equals -4. We add 8 to both sides. X to the 5/2 equals 4. And then to get rid of the 5/2, we raise both sides to the 2/5. We raise both sides to the 2/5. So these cancel each other out, leaving just x, and I can put 4 raised to the 2/5 in my calculator, and I get 1.74. So that's how you solve and deal with fractional exponents.